I want to make sure that we get started so Senna has the most chance to get her talk in. Okay, welcome all of you to our presentation. I am very excited about this presentation. I have not experimented yet with the ideas, but they are so innovative and pretty exciting. We have two speakers, and we will have their presentations first, and then after their presentations, then we will have time for questions and answers. Our first speaker is Phyllis Goulart, and she is an industrial engineer. But as part of her association, as part of her membership in the Systems Thinking Association, she has worked with educators at various levels, starting in primary school, with various systems thinking concepts with their curriculum. So we are for over 10 years. And so we're very excited to have her present. And then Senna Yildiz Degemensi, and she is someone that we have worked with for a long time. She was a middle school science teacher, but her undergraduate degree is in physics education, and she has a master's degree in education from the University of Oulu in Finland. She is currently working on a PhD in teaching and learning with digital media from the Technical University of Munich. And she will also present more or less on the same topic, but from a more middle school perspective. So without talking anymore, I would like to invite Phyllis to begin. Thank you very much for being here.
Hello. Thank you for joining us. Today I am excited to share how we are using AI-assisted course design for preschool level. And before starting, just a quick note, the full presentation link will be shared on the Systems Dynamic Society website later. Okay, our journey began in 2019, 7 years ago, when we published a training program for systems thinking in education. We are using a mix of videos, exercises, and face-to-face workshop in this training. While the core concepts are the same from preschool all the way to high school, but it's important to understand how system thinking is applied at different levels. So we realized we couldn't just use the same content for everyone. And that's why we started this redesign. To make this happen, we use a tool called Teledraw Computer. Before we dive in, let me give you a quick intro to it. Here there is a panel. Okay, I am providing inputs here, like, sorry. Okay, as instruction, I said make a story. Sorry. And the result might be image or text. Again, I choose text format. When I run instruction, we will get the result in text. This is free, first of all, and you can draw simple shapes, and AI turns them into the code, text, or visuals. Yes, here. I will keep this here. Later you will read it if you want. This very long story here. Okay, now let's look at the example. We are going to look at attendance chart in classroom. For this, here you will see it's like a chain of instructions, all of it. How we start? Here, we started by writing down steps for implementing in attendance chart in classroom. And we combined those with Turkish Ministry of National Education Preschool learning outcomes. Some more inputs as a visual here, image. And finally, we ask the AI, take all this into the story. This one is our story. It gives the story. We added more inputs like systems thinking tools to be used, change over time graph, and target audience, teachers and teacher candidates. The video's narrative style should be like one colleague explaining something to another. With all these inputs, we write down the list of instructions. Prepare content for a short video on systems thinking and attendance chart using the Moodle-based teacher training development procedure. This comes from here, procedure is here. For this, we started writing down typical instructional sequence and give this instruction. Using the given instructional design method, define the steps required for Moodle-based online teacher training. The online training will focus on the use of systems thinking at the K-12 level. So we got this procedure. And as an instruction, we said use this. Others, the video content should consist of two parts. Description of the video's visual flow, writing the text to match the visual flow. The context of the topics covered in the video should be consistent with the Ministry of National Education model. The video duration should not exceed a few minutes. And remember to update the video visual and text in a way that allows us to receive answers to any assessment questions. These are instructions. And finally, we got a visual graph, attendance graph, and with system thinking. This includes the visuals and voice over text. We didn't stop here. We said, prepare 3 questions, evaluate this content. Here we got the questions. Ask again, prepare the expected answers to these questions. Here, question and answers we got. and later review and update the video content based on the expected responses. Finally, updated visual draft is here. I'm not teacher, so one of our teachers reviewed this content. She changed something. At the end, we use this one, what she approved. I mean, this is the content of our video about attendance chart. Later, we gave another instruction like this. Create a formative assessment for teachers taking this course and complete the models. And here, there are three assessment questions. We transferred these questions to Moodle platform. I got a screenshot from the Moodle platform. This is one question, and we defined expected answers to these questions here. You will see in English the question. By the way, the cloud-assisted quiz Moodle plugin integrates with Cloud AI on the Moodle platform to automatically evaluate answers according to our expected answers. Here, we tested with average answers. Okay, this is the answers. The score is 4 in 10. We just give average answers. You will see how detailed a comment we received here. Just a look, overall assessment, correct points, areas of improvements. So for one question and one answer, it gives this comment to us. You will read it later. This is just a sample. Let's go with others. We selected a total of 4 applications for preschool level. Okay, attendance chart and bus game. These are the most popular games to date. Attendance chart illustrates behavior over time graph. Bus game illustrates stock flow diagram. And we have 2 storybooks for preschool. One is Oh My Green Files. Other book, Singing Frogs. These are written by, based on system thinking, and they were written by 2 teachers who are members of System Thinking Association in Turkey. All this work has not been complete yet. We are experimenting and changing many things on the way. We are still learning, but for now, that's all. Thank you for listening. You can examine all the detail via the link. Thank you for now.
Thank you, Phyllis. Thank you very much. Sena?
So now I'm sharing my screen. So hello everyone again. And thank you, Phyllis, for explaining the TL draw and how it is working, because everything I'm going to explain here will be based on that, and all the things that you explained with the functionalities that I will try to show you another example from the middle school level, so that I think it will then hopefully create an example how to use TL Draw computer for making courses like this. Everything we have done here, I have done it together with Emre Göktepe. So I'm just the presenter just to be on the, just to say it. Okay, so we started with the aim that we want to design a teacher training module that would tell teachers how to teach force and motions using stock flow diagramming. Why we started with force and motion? Because this topic is explained in the middle school as well as in high school, starting from the very basic parts of velocity and the position and acceleration, then adding the force, then going to the energy. So this is already inherently as like a structured problem that we can go one by one, adding little by little. But this is not so much present in the current curricula when we are teaching this topic. But once we included stock flow diagramming, then we can actually make it like a puzzle, starting from the very simple part and then making it more complex and explaining everything related to force and motion and putting everything actually in one model. So that's why we wanted to show this to teachers, then they can also use it in their classroom. And to make the course, then we use the TL Draw computer. So on the right side here, you see the whole video structuring. So what is important in TL Draw computer is, and how it is different from the other AIs that we are using with, for example, with chatbots and so on. Many times when we are working with the chatbots, that the process is in a linear process. Here we can make it, we can put it through the loops, as well as we can change some parts, leaving the other parts the same, and then see how it is changing. So we can create a structure on the map, and then we can copy the structure and then try something else, or we can connect these structures together as well. So what was important for us, the input blocks meaning the blocks that are shaping the first text created by the AI used in TL Draw. So our input blocks was a teacher training framework, which Phyllis also mentioned that it was a task central instructional strategy guideline, like how an instruction should look like. Another one is learning objectives from the curriculum. So here we had the learning objectives related to force and motion, and the core systems thinking concepts that like what kind of tools should be used while explaining this topic. And then here you see, so this structure, one structure is for one video. The second is the second, third, and fourth video. And these input blocks are visible here. And for every input block, we put some things similar, like for example, for every one of them, we had the same teacher training framework, but everyone had different learning objectives. So the second part we put here, all the learning objectives were different for each video, and the core system thinking concepts, then we embedded, some is the same, some is different. And then here you see how we are doing it. So this is showing like speed and the position, and so this is going to be our core stock flow diagram to explain it in the video text. And what is the topic of the video, and what are the learning objectives, what tools will be used, and this is for teachers and pre-service teachers, and the video should be explained in a way that is not so didactic, but from teacher to teacher. And here you see the instructional sequence text, and this is creating a Moodle-based teacher training program here. So these are our input blocks that we are always starting the video with. Then we have the instructions. So all these arrows are coming from the input blocks. Then we have a prompt for the instruction. And then here we tell it to create a Moodle-style course outline, match each learning objective with the topic, and sequence the content from simple to complex, and connect each part to the main stock flow model. So this is actually exactly the same how you would talk to ChatGPT, like giving the, okay, these are my documents and create me a Moodle-style course outline with this, and this. Instead of this chatting way, then we are putting it inside this box, and you can also change it later. Then the AI production starts. So this was the first text that it created after the instruction. So it gives like, this is the introduction and how you're going to activate the knowledge, and how you can start with this stock flow diagram. So it is actually giving a video text that we can use later. And then after this, we added another instruction, which is a create a formative assessment, as Phyllis also shared. Then this is creating a formative assessment based on the video text presented here. And then we connect another instruction to this formative assessment text. It is here. For each question, give expected answers. Then for the questions that it created, we also have some example answers here. And what is good about this part, now I really like this part, because after it creates the expected answers, then we have connected kind of a checking tool that it checks the expected answers. So after the formative assessment, we have some answers, and based on these answers, it goes back to instruction. The instruction is fed again to check if the content is aligned with the created formative assessment questions. And this is done 3 times. So once we open the toggle bar here, then this process goes over 3 times to check if the content is created based on the assessment questions that we had. So here you see the 3 videos are connected to each other. So these were the input blocks for the second video. And now we have another input block here, you see. And the same for the third video, we have another input block coming from the second video. And this is done to ensure that this video knows about the video previously, so that it is built on top of the previous one. And same for the other one. And this is the human part. So we have created all the text videos. Then we copied everything from here to a simple document that checked for every part that is created, that if it is very sensible, like does it make sense in teacher training, and does it make sense in the content when we are teaching for some motions, because sometimes there can be mismatches as well. There were many, like there can be conceptual mistakes. And we've added some classroom-based examples. This actually we did manually, but this can be also included in the structure as an input block. So if you have already some available classroom examples, that it can get this and then create an example based on what you have provided before. And then we use ChatGPT to refine the explanation. So we were just checking for the mistakes and unclear parts, and then making the text again beautiful for the video text. Then we used ChatGPT for the refinement. And what we have as an outcome, the course flow. So now we have the structure for all the videos to be created under force and motion, then video texts. And now we are creating the videos based on the refinements, and we have the assessment questions. So you see some of the screenshots from the videos here, how it is starting. Then it is starting with comparing how we are teaching it in the classroom with the concept maps and the equations, and how can this be translated into stock flow diagrams, and then how this is connected with the learning objectives, and then seeing it at the levels from the events till the structures. So this was the suggestion for the first video of the introduction to systems thinking, and why should we use systems thinking for teaching science in the middle school. So thank you very much. this was the end of my presentation.
Thank you. Thank you. Both of those were very helpful. Both of those presentations were very helpful. Emre, can you put in the URL for finding this software? It is the
yes,
free
of course.
software into the chat so everybody can find it. And then just to make sure, Phyllis said that when we post this recording, she will include a link to her structure. Now, it's somewhat in Turkish, but you can see some in English and some in Turkish, but you can see the structure that she set up to just look at her examples, but you won't have that right now. Are you going to, Phyllis, can you put that link in the chat or now or not?
Okay.
That would be great. So please, I'm opening this up. Senna needs to leave in 4 minutes. She has another meeting and she'll come back if she can. But she and Emre worked together a lot on the part that she presented, so you could ask him questions. But please ask any questions that you have at this point.
I have a question.
Rafat?
This is fascinating. Thank you for sharing. My understanding is the objective is to create a video at the end. Did you reach that stage of creating those videos? And do you know which model that this software uses as a background that runs in the background?
Well, I can talk about the video part firstly, maybe. So we have created the first video already. So the last screenshots that I shared was already from the video. Video creation, not to be misunderstood, this is again human-made. So I've got the text. So based on this text, then I started creating the video and I kind of voiced over on it with the text that we created. So, and the other videos are in production right now. So easy
Same
answer
for
is yes, we have.
Thank you.
Can you
Great
show us
work.
a video? Can you show us a video?
Yeah, I can, but it's in Turkish.
That's okay. We'll get the idea.
Okay, I will just share here.
Then if you don't have time, I can do that.
I will just share the video, then maybe I can leave.
Okay.
So here it is. I don't know if you will hear the sound though.
No.
Do you hear the audio?
No, no sound.
No, okay.
Maybe
One thing, then I will just share with the audio again.
with the sound. Mhm.
Mm-hmm. Oh, not that one. Mhm.
Merhaba. Bu video serisinde Fen Bilimleri dersinde kuvvet ve hareket konularını nasıl farklı bir açıdan ele alabileceğimizi inceleyeceğiz. Kuvvet ve hareketle ilgili kavramlar doğası gereği zaman içinde değişen ve birbirini etkileyen değişkenlerdir. Örneğin bir cismin hızının artışını konuşurken aynı zamanda cisme etki eden kuvvetler, cismin kütlesi, alınan yol gibi diğer faktörleri de ilişkilendirmemiz gerekir. Bu ilişkilerin dinamiğini farklı seviyelerde farklı detaylardaki formüllerle tek tek ele almak kolay olsa da hepsini bir arada aynı görsel ya da model üzerinde göstermek zorlaşabilir. Sistem düşüncesi araçları bu dinamik ilişkileri görünür kılmak ve öğrencilerin neden-sonuç bağlantılarını bir bütün olarak kavramasını sağlamak için kullanılabilir. Öğretim programları öğrencilerden sadece bilgiyi hatırlamalarını değil, örüntüleri fark etmelerini, kavramlar arasındaki ilişkileri kurmalarını ve değişimleri anlamlandırma becerilerini geliştirmelerini de bekler. Fen bilimleri dersinde simülasyonları bu tarz becerileri geliştirmek için sık sık kullanırız. Simülasyonlar öğrencilere bir süreci adım adım gözlemleme, değişkenleri kontrol etme ve sonuçları karşılaştırma fırsatı verir. Ancak bunun yanında öğrencilerin gözlemledikleri süreci açıklamaları, kendi ifadeleriyle yeniden kurmaları ve neden-sonuç ilişkilerini de anlamlandırmaları gerekir. Sistem düşüncesi araçları bu farkındalığı destekleyerek öğrencilerin karmaşık olguların neden-sonuç örüntülerini keşfetmesini sağlar.
So far I was explaining why should we use systems thinking in the classroom. And the second video comes starting from this side and explaining how can we teach students to use this structure as a beginning when we are talking about motion, how motion happens, and then how the position is influenced by the velocity, and then how velocity is influenced by the acceleration, and how force is influencing all these structures. Then explaining in each video each part of this model here.
I see that it's 31, so I know you need to leave, Sena. Thank you
Okay.
very much for that. And as
Thank
far as
you.
very, very, very nice. Thank you. As
Okay.
far as I understand, yes, I agree. As far as I understand, the video is a human creation
Yes.
from using the information that the structure of the AI in that software was shown first. All the pieces were created there and then put together in the video. That's right, Emre?
Yes, we used AI as an assistant, so it just created the drafts, and all of them are reviewed by humans, teachers, human teachers.
Go ahead, Phyllis.
Our teachers reviewed all of the result of TL computer, and then some point she said, okay, I want to change this, I want to say this, don't want to tell about this. So she reviewed, approved the content, video content, and then we use this last one. We didn't use directly what a big changes, but we changed something.
So it's very easy. Well, two things. One, there is human oversight of the product. Yes. You have an actual teacher going through to make sure that each of the pieces makes sense. And number two, once there is a correction, it easily updates everything.
Yes.
So that's really interesting. Dawn said something in the chat. You can easily add instruction blocks in the computer in computer.tldraw to translate the Turkish into English or other languages. Thank you, Dawn. That's really helpful and very important for us who don't know Turkish. So that's great. And Rafat, we're sad to see him go, but we were happy he was with us. Any other questions, please?
And one more thing to add, do not hesitate to do any kind of changes in the TL file, because you just fork it. You make a copy of yourself. So you cannot change anything in the original file. So don't be afraid. You can just play with the file.
And I recommend this is the free to use the TL computer. You can copy all my presentation and translate in English and try many things on it. You can keep the base and then copy and change
whatever
you want.
Yeah, whatever you want. Yeah,
so
great.
Whatever you want. So it's good, I think. Just play with it.
I have some more questions, but I'd like to leave it open for other people who want to ask questions before I kind of take over things. Anyone else like to ask any questions? Martha?
Thanks, Nana. Fantastic presentations. So this is going to be more a big picture question and back to technical details. Has AI, with how you're using it now, how is it influencing or not when people ask me, and I want to justify things, why teach systems thinking in public education? I've got a raft of answers and I have to distill out, well, I've got someone's attention for maybe 30 seconds here. I don't want to do deep dives straight off the platter. But AI is everywhere, and people understand this thing about AI and they wonder about it. Can there be any update in my answer from your experience using AI in the classroom settings? Can there be any update to my answer about why we should be teaching, or what's the benefit? I guess what are the benefits of teaching systems thinking in public education? I'm not talking university. I'm talking public I'm talking K to 12. Is AI changing your teachers' answer to that very, very basic question? Like I'd kind of like to say, well, and here's why. But guess what? Now in our AI world and in our information economy, that's all the more reason, blah, 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 you know. And if there's no answer, that's fine too. I'm just curious. I'm trying to stay up with the leading developments in systems thinking in public education so that I can give people, a timely, I guess, answer. But if there is no answer to that, then I guess I'm as up to date as possible. I'm curious about how you, as people who are on the floor in the trenches, do boots on the ground, doing the teaching. How do you answer that question nowadays? Why teach systems thinking in public education? I'd like to be able to answer this. I mean, it's a loaded question. We all know it's a very loaded question, but they don't know what they're asking. They don't know the difficulty of this very simple question.
May I?
Yes, go ahead, because I have some answers that I would like to say too. Go ahead, Emery.
Yay, I'm so glad. Thank you.
What I've been thinking about this for some time, and probably we are focusing too much on systems thinking term. I think the real advantage for the public, so the public education, is these tools improves thinking, not systems thinking, just thinking. We can go into detail which kind of thinking and forced thinking, stock flow thinking, or feedback thinking, but in the end, it is thinking. So because it is much better to, it is much easier to communicate thinking. You don't need to explain what systems thinking is. These tools improves your thinking, but then you have to prove this, or you have to show something that this works. That's why I'm a little bit hesitant on jumping on feedback portion of systems thinking, because when you use stock flow tool, stock flow diagrams, this gives a discipline to your thinking, which are the things that are accumulating, and what are the things that changes those accumulation, and what are the things that are affecting those changes, including other accumulating things or stocks. So this gradually you can just increase your understanding of the system or the problem you are in. So that's how I, because this is very easy. You give the problem and you ask to analyze it and give, if you have any solutions or ideas, give them before the lesson or course, and you ask the same question and now answer this question with the tools you have. And almost always there is a much richer picture, literally picture. So this might be used as a proof or a kind of persuading approach that it works. It makes you a better thinker. Thank you.
Thank you, Emre. Don?
Yeah, I agree with everything that Emre said. A few other things from my work. So, at least in the U.S., the way we teach most subjects, everything is very siloed, right? And so the math is siloed from the social studies, from the language, from science, and a student leaves one class and goes to the other, and everything just becomes meaningless, right? And we have a real problem with just students understanding the relevance of what it is that they're learning. And so if you can, break down those silos, right, the problems that they encounter in the real world are not siloed problems, right? So, I think there's a lot of value in just approaching education from a philosophy that all of these things are interconnected. And, if we want to go to more experiential learning, problem-based learning, things like that, we need to get rid of those silos. And the teachers, especially the math teachers I work with, I mean, they have no idea how to make math relevant outside of the math classroom. So.
I agree. I would also like to say, Martha, very young children think systemically. They connect everything together because that's the way their world is. When they get into education, so Don sort of took some of the power from what I was going to say. When they get into education, we start to separate things too much. And if we want to help children retain their natural way of thinking when they are preschool, when they are before entering school, systems thinking is a way to keep that holistic thinking alive. And that is what we need in adults. So we absolutely need to make that part of our educational process. And that's why it needs to start in preschool and kindergarten and all that, because the kids already think a lot that way, and we need to keep that, even especially at the young ages, because it gets worse and worse and worse. So if we can keep this holistic thinking alive longer while they're in elementary school, then they will bring that to the upper grades, which just get worse and worse and worse as we go on. Okay, so that's what I wanted to say.
Okay, all very helpful. Thank you, thank you.
Happy Tybo says, any chance you can share the story of TI Draw software development? What AI software you are using for TI Draw? Now, TI Draw is not for us. It's a commercial free software, right? Well, commercial means
it's kind
not
of
free, but yeah.
Yeah, it's not exactly open source. It's free to use. But so TL Draw by itself is really just a web canvas. It's very neutral. It's actually used to support a lot of applications. So like the the causal loop diagramming that Skip Design Ed uses in their application. For anybody who's seen that, that's also built on top of TLDraw. And then computer TLDraw is just an extension. It ties into, I believe, Google's DeepMind AI engine. If that, Emre, do you know if that's?
I think it sends to Gemini, but I don't know which one, which version of.
Yeah, Google has like three different AI engines that I think that they use, but I think it's DeepMind, which is more analytical.
Are there any other questions? Phyllis, I would really like you, if you can, open up computer.tlddraw and explain some of those tools on the side, because I think instruction is like prompt, right? Instruction is like a prompt to the AI engine. So maybe you could show us some of those tools and give us a little explanation of what some of the tools do.
Okay.
Sorry, I don't mean to put you on the spot, but I was interested when you started showing us things to actually see what the tools were that we had a choice of.
You mean the panels?
Yeah, on the left. So text, I understand. You're just putting some information in there. Instruction is like a prompt to the AI.
Yes.
And then go ahead.
Where's my, oops, pardon. For example, here we will choose image as well. We would ask the result as an image. Oops. Sorry. How?
Now you have 4 of them.
My computer is tired. Oops. Pardon. It's slowing down now. Anyway, image we can use as an input, or the result we could ask as an image, but I don't find it so successful to get something in image. I didn't like too much. It's in text format is better. Model, up to now, I haven't tried to give a model or to get the result as a model. But we can use camera and some websites. For example, I'm so sorry, my computer doesn't move. For example, website, do you remember Turkish Ministry of, I got outcomes for 60 and 72 months. This was a website. The program went to a website and then get the input from there. We could put files and some data. I don't know the others. I just try this. That's all.
Yeah, thank you. That's great. I just kind of wanted to see what some of the choices were and what you knew about it, because I know nothing about it. So it gives me a little bit of a head start to understand some of that. Is there anyone else who would like to ask questions? You know, the person on the parabola who was skating up and down, looked like with a little snowboard. That came from the FET website, didn't it?
Yes.
Yeah. PHET. They have a lot of science simulations for K-12. Probably not K, probably a little bit higher than K, but they have a lot of science simulations. And so that's one of the things they used from PHET. Oh, there it is. Thank you, Emre. PHET.colorado.edu. I recommend looking at those if you would be trying this and wanting to create some of your own videos. That's a terrific resource with some very nice simulations for science. I really like the way Senna took what the TL draw had constructed for her force and position, for her position and velocity and force, etc. I like the way her progression of ideas, where in her video she had the physical representation and then the graphical representation and then the stock flow representation, and then it was part of the iceberg. I thought that was so elegant. It's so impressive. And here she is using the computer TL draw to help construct some of the things that she has. But I like the consistency between the assessment questions that she was asking, or she had the AI create, and then the human looks it over and feeds back to the lesson construction, because that's always a hard thing for teachers, to make sure that their assessments are things they actually instructed about, that sometimes that connection can be lost. And I really liked the feeding back into the instruction part to make sure there's a consistency with what we expect from students and the way we are giving instruction. There were so many things there that were so nicely developed. So I hope you go back and look at the video if you want to get more detail. And I think we should play around with this stuff. And then maybe we can have an update, later in the year with people who have tried some things and experimented. And especially if there are teachers out there who don't have the time to do it, there are some of us who are retired who could work with you to try to develop some of this. We want to make these connections among our audience to try to bring the whole systems thinking in education force forward. I don't have anything else to say, but if anyone else would like to ask questions, please bring it up. If you have ideas for, okay, Martha.
Thank you. In terms of barriers and stumbling blocks to get wider ST acceptance and valuing in public education, K-12, I have a perception that one of these barriers is, well, teachers don't know, teachers who may want to teach it, they do not have an evaluating rubric and a means to assess and feel comfortable in their professional minds that they are, this student is showing this capacity, and yes, I can evaluate it in a rigorous and widely accepted, like in the whole systems thinking community or whatever branch, so that I feel that my job as a professional teacher is aligning with a common standard. Is there any progress being made in the area of how do we need to have a standard of evaluation? If so, what steps are being taken towards it? Is this thinking good? Maybe systems thinking can be helpful for students or trying to reach other existing standards of evaluation, like in a science subject or a drama subject.
Well, the
Help.
creative learning exchange, I think with significant help from Deb Linus, who was just a marvelous resource, created rubrics for understanding. And it is a very nice list. And I think it's broken into behavior over time graphs and causal loop diagrams. Understanding from the use of each of those tools and general understanding, I think I would definitely go to the Creative Learning Exchange. That's cle.org or the creativelearningexchange.org, and put in rubrics for understanding. I think you can just download it. Oh, thank you, Lou. It's in the chat. clexchange.org, and I would put in rubric for understanding. And I don't have it right at the top of my, I don't have it available immediately, but I would take a look at that because it's a very nicely structured document. Emery?
Addition to this, I think we should have we should prove that, or we should show that the current evaluations, that is the outcomes in the curriculum, are met with systems thinking tools much easier or much deeper. But if we try to assess or measure systems thinking with the questions or tools we created for systems thinking, so there is a danger of trapped within the same field. Our methods should work for thinking, not systems thinking, for thinking. So the students using systems thinking tools must be much better in current assessment scheme, or all current exams, national exams. They must be more successful using these tools. I think whenever this is shown to be true, then we won't have any problem infusing systems thinking tools, because like any other tool that is useful, it is by definition used because it will give you an advantage, a competitive advantage. But we need to show this within the rules of the current system.
What value is there being placed on? Thank you. This is great. What value is currently being placed on transferability of thinking? This takes me back to Barry Richmond's introduction to systems thinking, and there's a section in there where he's got a little stock of flow saying, "Oh, with systems thinking skills, your ability to make a presentation in history is going to be enhanced by making us a similar type of presentation in economics or physics." And there was an idea, that a concept that presentation skills and understanding skills are enhanced. The sum is or the whole is greater than the sum of the parts, I think was Barry's message. that if you learn things in one context, there's tremendous value. There's nonlinear value in actively transferring to other disciplines or domains. I confess, I still see I'll be blunt here. I see very little of that skill. Maybe it's just maybe I'm not seeing things. How please enlighten me as to what kind of follow through we're getting on Barry Richmond's statement, which was very attractive to me. I must say it was a huge draw into systems thinking and system dynamics. Was that topic of his right there, the transferability of skills thinking?
Well, I think you have to have some understanding in multiple disciplines to be able to see that transferability. But the one that I use all the time in my classes is the spread of an epidemic, because it can be used to show the spread of a disease. It can be used to show the spread of a marketing a product, and it can be used to show the spread of a social movement. So that's really one that is easy to do, because building the spread of a disease, just the sustainability, just the susceptible and infected piece without recovered or anything else, just those, that's all you need for the basic structure, that and two feedback loops, because it's obviously S-shaped growth. And that one, you want something that is easy enough to transfer, but you have to know something about the subjects that you're trying to say, here's another application. So it's not something that I think teachers in our siloed education, because the teachers were raised in a siloed education, and math teachers, as Dawn said, are notoriously siloed. Not only do we not know much about applications of what we're teaching, we ourselves are a little bit arrogant in thinking that the way we do things is the best way to do things. Okay. That's a hard idea to counteract. And it's really out of date, because too many math teachers are not bringing in new technology to enhance how to approach some of the ideas they're already teaching, because of their total dependence on equations. But that's another topic. The answer is, you have to know, to do that transfer, you have to have friends in other areas who also know the background that you know, or you yourself have to have some information about another area to know how to make the transfer apparent.
Okay.
Emre?
Okay.
And one more answer. It can be done actually within the same domain. For example, in science, you have the systems in our body. It's a biology subject, and another a physics subject, force and motion. The proxy, or the sign, or the evidence, or the real value for the teacher for transfer is that she wouldn't spend that much time explaining everything from the start. When you see that this is a stuck, and we had seen that speed was a stuck, or position was a stuck. So now the stomach, the ingredients or something, proteins in the stomach is a stuck. When you say this, you just you make a great abstraction first, but if the student can do this, it just retrieves all of the things that she had learned on that lesson. She only need to change the labels of the stocks to get the same or similar behaviors. So I think the thing is it should decrease the time of lecture or increase the depth of the lecture for the teacher. So the teacher should be the judge or the assessor of this transfer. She should see that.
We have in the chat, well, a couple things in the chat. You can download the rubrics for understanding right from the chat. Both I and Dawn included the file there, and Lou gave you the actual URL to it. So thank you very much. One way or the other, you can get it. Happy Taibu says, System Dynamics courses belong to which departments? First of all, we should not worry about System Dynamics courses in K-12. We really need to integrate systems thinking and system dynamics into the current curriculum, into math, into science, into social studies, into literature. We have had the fortune, some of us have been fortunate enough to be able to teach system dynamics classes. Some of them started in math, some of them started in science, some of them started in English class from an English teacher. So, but that's not the goal. The goal is to bring the systems thinking tools into our current curriculum. It needs to be integrated within our current curriculum. That's the goal. And how do we do that? Well, you have to have a teacher who is open to two things, willing to do things differently and willing to take some time to learn how to use the tools. You know, willing to work with someone who will help them learn, because there's a learning curve. Now that we have the tools free to us in K-12, there is no problem of expense. And most schools in this day and age have computer technology, internet access technology for students in general. Okay, other questions? Well, I guess a couple of things coming up. Next month, at the end, the last Thursday of the month, we will have a focus particularly on primary school. Linda Booth Sweeney will talk to us about a new book that she has coming out. And Sarah Stewart from the Borton School, who helps their primary teachers bring systems thinking into the classroom, will talk to us about some of the ideas that she helps teachers bring into the classroom. We will have a third person from Turkey, and I don't know, Emre is the one who knows what she's going to talk about. Do you want to say what she's going to talk about?
Well, we developed some lessons aligned with our curriculum, the new published curriculum in 2024, that indirectly requires system literacy skills. So we will give some examples how we are using these 3 or 4 lessons. They are implemented and with their results, but we will have probably 10 minutes, not.
Thank you. And then don't forget, March 21st, we will have our pre-college systems thinking symposium, 5 hours. And we started this last year in March. So on March 21st of this year, it will start on the West Coast of the United States, will be 7 a.m. It runs for 5 hours. In Turkey, it starts at 5 p.m. and runs for 5 hours. So In between those two ends, you'll have to figure out what the time is. It's 10 a.m. Eastern Daylight Time in the United States for New York. We have some interesting speakers, and we hope that you will come. We will start advertising that probably in another month or so. But we hope that you will attend some or all of that. We will bring some speakers to you with some interesting ideas. Thank you very much for attending. We really appreciate you as an audience. And the Phyllis and Senna, we thank you for taking the time to make these presentations. It really helps us all to see what you have done.
Thank you for listening.
Thank you. See you all next month. Thank you. Bye. Save the chat. There's good stuff in the chat.
So,
Thank you. Bye-bye.
Bye. Bye.
so I'm stopping the recording.
Recording. Thank you.